Alright, so since this is my first video, I'm just going to give a little explanation about the channel. Basically, I'm just going to be solving homework problems like I get in class, and I'm going to be explaining these problems like I would be explaining them to another person in my class. This channel is just basically me documenting my thought process, and that's pretty much it. If someone learned something, I'm super happy about that. But if nobody learned something, then you can unsubscribe and block me. Alright, yeah, let's get into the video. The first thing I'm going to be solving is Program 5 for my computer science class. So we need to make an array that can grow and shrink as needed. This is called a dynamic array. So we have to write a dynamic array which can hold double values. And adheres to the following. So the physical size of the array at all times is a non-negative power of 2. So the smallest of the array can be 1, and that checks out because 2 to the power of 0 is 1. Uh, and then the physical size is never more than 2 times the number of elements which occupy it. Okay. So let's try to break this down real quick. Let's try to actually figure out what they actually mean by all this stuff. So let's use my favorite tool for problem solving, MS Paint. So when they say that the physical size, they say when they say the physical size of an array is a non-negative power of 2, we could draw a table to actually figure out what the array is going to look like. So if we made a little table, right? This will be our y. Oh my god. This will be our y. There we go. This will be our x, which will be 2 to the x power, because our array is growing by non-negative powers of 2, which means it's starting at 0. So 2 to the 0 power is 1. So this will be one possible size of our array. Then we'll do 2 to the first power, which is 2. Then we'll have 2 to the second power, which is 4. And then we'll do 2 to the third power, which will be 8, and so on. You know, the higher power of 2 we go, the larger our array will get, and it'll be proportional to this. The other parameter they said was that the physical size of our array is never more than 2 times the number of elements which occupy it. All this is trying to say is that we can never have, so let's draw our array real quick. So we're drawing an array. This is how many possible spaces we can put elements in our array. So right now our array can hold 1, 2, 3, 4, 5, 6, 7 elements. Let's make it an even number, 8 elements. So what they're saying is that our array can never hold 2 times the number of elements which occupy it. So that's saying that we can never have 2 times as much space, or we can never have more than 2 times as much space as stuff inside of them. So for example, something that is acceptable is if we had 4 elements in here, because we have 4 elements. All right, pretend these are elements. We have 4 elements and 8 spaces to hold them. So this is fine because our elements are taking up exactly half the array. And it's also fine that the elements take up more than half of the array. So we could have 7 elements in an array of size 8. But it is not okay, according to the program, to have, let's say this is 1, 2, 3, 4. It's never okay to have an elements that take up less than half of the array. So right now this is 3 elements inside of an array that has size 8. We can only have elements that take up half or more than half of the array. So these are two, so right here, these are two parameters that we have to keep track of to make sure our assignment works successfully. So let's hop back into the parameters and read a little bit more about how we have to approach this problem. They give us some mandatory instance variables that we'll need to implement. They give us some instance methods that we'll have to implement. Here they just give us a little bit of code to use. And then they also give us a driver class. So in this program, they're giving us a driver to test our method. So we're not actually writing the driver. We're just writing methods that will work inside of this driver. So your class must work with this driver. So we can actually copy paste this driver and put it into our program. So now I can load up the IDE. Oops. And let's open it up. So we can go to new class, dynamic array driver. That's the name they want us to have. Clicking it. All right, now we can just copy paste. And so we're going to have a few errors when we copy paste a class into our program. The first error is that this dynamic array is probably going to say can't be resolved to a type. It can't be resolved to a type because we never made a class named dynamic array inside of this folder. So it doesn't really understand what this means because it hasn't been created yet. The same also holds true for these methods that are in white. Array size, elements, insert. These are methods that we'll have to add later. And when they start getting added one by one, then these will go away. Or then they'll change color and then we'll actually be able to use them. So let's hop back into the requirements here. Okay, so it looks like we have some mandatory instance variables. We have to make an array. We have to make an array of type double. We have to make a variable called size of type int and a variable called next index of type int. Since these are written correctly, syntactically, we can just kind of copy paste them into our program here. After we make a new class, so new class, dynamic array, finish. Okay, boom. We got this, and we can just copy paste these in here. Perfect. Okay. So now that we have this, we can talk about our first method that we have to add. So we have to add a default constructor. What a default constructor is that anytime an object of the class is made, it will be made with certain values that we can determine. So the values that we want to have determined, we want the size of the array to be a new double of size 1. Then we want to set the size to 1 and the next index to 0. So size does not actually scale, or size does not actually keep track of array directly. We have to scale size with array, or with the actual size of the array to make sure that it stays in line. Same thing with next index. So what the next index is supposed to mean is the next possible index that you can insert a value at. So right now we're making an array. Actually, it might be easier to hop on MS Paint and explain this. So right now when we make a new object of type dyn array, when we make an object of this from this class, it's going to be an empty container. That's all we're saying. We're saying we're making an empty container and the next possible index is at spot 0 because all indexes start at 0. So basically we're saying this is an empty box and there is nothing inside of it. That's all that this default constructor is saying. We're just making an empty box. So now we have to take this and put it into code. So let's hop back into our IDE. All right, so let's try to actually code this up. So the first requirement is to make a dynamic array constructor. And we just want to recap, we just want to set the array variable to a new array of double of size 1, then set the size to 1 and the next index to 0. So we have our three variables already initialized. We're going to open up our IDE here. And so the way to make a constructor is you just do public and then the name of the class. So in this case, we will do public and the name of the class, which is dynamic array, or DYN array for short. Every time you make a constructor, you're going to need these parentheses, and then you will need a set of curly braces. And then we can start coding it up. So because the variables we declared up here are private, we're going to need the this keyword to access them in our method here. So every time we set a variable or we declare a variable here, we're going to use the this keyword. So this dot array equals new array, or new, and then this will be the type of the array, the type that the array will hold, so double. And then the size of this array is 1, as specified in the instructions. And then we're going to do this. We're going to use this keyword again for size. And then we're going to set this equal to 1. And then this dot next index. Is that right? Yeah. Equals 0. And so what we did here is we basically did what I kind of described in MS Paint, where we just made a blank container that holds doubles, but currently there is nothing inside of them. So that's all that we need to do for this first method. All right, so let's start working on some other methods. Let's close this out and read the requirements again. So it looks like we just need to make two accessors. We need to make an accessor named array size and another accessor named elements. And all accessors do is just return the value of your private data. So let's just quickly make one real quick, and then we can just kind of explain it as we go. So to make an accessor, accessors are public, so we'll just do public. Public, and then the return type. So the return type for this one, the return type for both of them will be int, because these private variables are both int. So public int array, and then we'll need our parentheses, then we'll need our braces here, and then all we're going to do is return size, just like this. And then we'll do the same thing for the other ones here. So we'll do public int elements. And then we just need parentheses and some curly braces. And then we're just going to return next index. Index with a capital I. And the reason we're calling this elements is because it just counts how many elements are going to be in our array. And the next index effectively counts that, because the next available index will be the total amount of elements. All right, so let's take a look at the at method here. So they gave us a good amount of pseudocode here. So basically they say public, then the return type is type double, the name of the method is at, and then they take one parameter called index. And so basically they're trying to see if 0 is greater than or equal to index and less than next index, return the value of array at that index, or return null. So we can try to conceptualize this or try to visualize this using some MS Paint here. Try to access MS Paint. Okay. So all that's saying, star array here, quick array. Here. Let's say this is the value of next index. So 0, 1, 2, 3, 4. 4 is the value of next index here. Basically, if our number, and this will be 0, if our index is anywhere in between 0 and 4, then we will pull it and find its value. So let's say that we have, actually, here, let's use real numbers. Let's not use dots. So let's say this is 1.0 because these are type doubles inside our array. Let's say this is 2.0 and 3.0. And remember, this is index 0, 1, 2. So let's say we call array dot at, and then we pass in 1 as our index. This should return 2.0 because we're asking the array what its value is at index 1, which should return the value of 2.0. So pretty simple, but now let's try to actually work this into some code here. Okay, so the first thing we have to do is kind of do what the pseudocode told us and do public double, because this is a return type, at, which is the name of this method, some parentheses, and inside the parentheses, we're going to put a value of type int called index. And then we'll need our curly braces. So now we can use an if statement to check if it's inside of the range. Because remember, we want to see if our value is actually inside the range or not. So we can use an if statement to check. So we can say if 0, it's kind of just like how the program specified. So remember, if statements are going to need parentheses here. 0 is less than or equal to index, and bad at the keyboard here, and index is less than next index, then for our if statement, we can use some curly braces as well. So we're basically saying if this is inside our array, then return array at index, at the index that they asked for. Okay. Now, to follow the other part of the requirement, basically saying if it's not inside the index, then we're just going to return null. Else return just like this. And that is basically how the at method will work. All right, let's move on to the grow and shrink method. So they give us a little bit of pseudocode here, which is just saying the return type should be void. And so the parameters for this method is make a reference to an array that's twice as large and contains the same values, indices 0 through next index minus 1, and adjust the size appropriately. So what this is trying to say, and let me hop on trusty MS Paint here. Let me actually do it on my screen here. No. Okay. So when we copy the array, we have to make a reference to an array that's twice as large. So the goal of this method is that when our array is full, for example, let's just use dots again. Let's say our array is completely full. Each index is filled. What we're trying to do is make another array. Okay, I mean, I don't know why I made it so big, but basically we're making an array that's twice as big. So this had size 4. This array will have size 8. 1, 2, 3, 4, 5, 6, 7, 8. And what we're going to do, now that we made a bigger array, we're going to copy the values from the smaller array into this bigger array. That way, we come out with a new array of a bigger size that has the same things, the same contents inside this array, but now it has the size of this array. So the goal is to have an array that has more space. Sorry for my poor drawing. I'm not an artist. I'm a comp sci major, but basically this is the goal of the method. And this is how we're going to achieve it. So now that we kind of have a general idea of how this is going to work, let's try to actually code this up. I had this written before, but we'll just rewrite it. So the first thing we know is that it's going to have a return type of void. So we could just type that out, public void, and the name of the method is grow. Grow. And then we're going to have parentheses and we're going to have our braces. So the first thing we're going to need to do is make our bigger array to reference to. So we can just declare it. And you can name it whatever you want. I'm just going to name it big array. Because it's easy. Big array. And since it's an array, we're going to need the square brackets here. This is going to be equal to a new double. So this is a new array of type double. And the size of the array will be this dot size times 2, because we're making the array twice as big as our previous array. Now that we make our new array, we can use a for loop to copy all the elements from our array into big array. So how we're going to achieve that is just by writing a for loop. So for int I equals 0, I less than next index, because we're going to go through all the available elements in the array. And then I plus plus. And then all we're going to say in this for loop is that big array. So the elements at big array are going to be copied over. Oops. They're going to be copied over from this dot array. So we're taking our smaller array and we're copying them over into our bigger array, just like so. Oh, it's going to bother me. Okay. Wait. Oh, it's got messed up. There we go. Okay, I was getting real confused. So this is here, this is here. Okay, great. Now that we copied all our elements into the big array, we're going to give array, we're going to give big array the same address and memory as array. So array is going to be equal to big array, just like this. And then we're also going to increment the size, or we're going to adjust the size variable. So size is going to be start equal to, just like this. This is basically multiplying the size variable by 2. So now that we have the grow method written down, we can get started on the shrink method. So shrink is very similar to grow, but I will hop on MS Paint just to try to visualize this, because it's better to be safe than sorry. So let's say we have a big array. Let's say we have 1, 2. Let's try to make it even. 1, 2, 3, 4, 5, 6. Okay, say we have 6, and we have half the array we're using, and we're not using this other half. Well, what we can do is shrink the array. And what the program wants us to do is shrink the array to where we only have a full container. So we're using every single spot of this index. So we're going to achieve this the exact same way as we achieve the grow method. We're going to make a smaller array. So here, I'm just actually going to go to a new page here. So we're going to start with our array. This is going to be array. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, great. So we have 3 elements. Then we're going to make a smaller array. And then we're going to copy the elements into here, just like we did to the last time, and then this will be our new array. So let's try to code that up. All right. So same thing here. We could actually almost copy this, but I'm just going to type it out. So we have double small array, and this is going to be equal to new double, and we're going to do this dot size divided by 2. And the reason we're doing divided by 2 is because we're actually making a smaller array, and this one is making the bigger array. We can do the exact same thing when it comes to copying the contents. We're just going to use a for loop here. So for int I equals 0, I less than next index, and I plus plus, small array at I is going to equal this dot array at I. Oops. So we're taking all, why is it wrong? So we're taking all the values from this array and putting them into the smaller array. So same exact thing, we're going to give this the same address and memory as array, because remember, we're not really using the small array variable, we're just making array bigger, or making array smaller. So that's why we're giving big and small array the same address and memory as array, because we still want to access, we still want to use array. We don't want to use small or big array. So we're going to do array equals small array, and then we're going to adjust the size variable accordingly. So I think it's divided equals 2. All right, perfect. So that's how you make the grow and shrink methods. All right, so let's talk about the insert at method. So they give us a bit of pseudocode here where it's public, the return type is void, the name of the method's insert at, and it takes in 2 parameters. So the parameters are index, which is type int, and value, which is type double. So this is the same thing as the at method, where basically we're just saying if this is inside of our array, then we're going to move the values over so that the value can be accommodated, and grow method might have to be applied. So let's try to conceptualize this using MS Paint again. Let me switch this over. Okay, so let's say we have an array. And this is an array of type double, so we're going to fill it with doubles. So we have 0.0, let's say 1.1, 2.2, but we want to insert 4.4 at index 1. Well, the way we're going to do that is we're going to move 1.1 over to this slot, and then we're going to move 2.2 over to this slot. So 4.4 can have an empty slot to be accommodated into. So the new array, so after we do this and we move everything over, the result will look as follows. So 0.0 will remain unchanged. It'll remain in its index. 4.4 will be moved into this slot, which will leave 1.1 moving over and 2.2 moving over as well. This had 2 extra spaces, so we'll just keep that consistent. So this is exactly what it'll look like. But what if the array is full? Let's say we have 0.0, 1.1, 2.2, just like this, and there's only 3 slots in the array. We want to add 4.4, but there's nowhere to put it. Every single spot is filled. We can't move 2.2 over here. This doesn't exist. So what we're going to have to do is use the grow method. So In the grow method, we said if our array is full, it's going to use dots. If our array is full, then we're going to copy these values over and put them in a bigger box, basically. So we're going to same stuff, different box. And we can do the same thing with our doubles. So if we have 0.0, 1.1, and 2.2, and we want to put 4.4 in here, we can just copy all of these over to a bigger box, and it would look like this. So we make our bigger box, then we copy them over. Copy all of them over. 0.0, we get our 1.1 and our 2.2. But wait, what happened to 4.4? Well, we're going to copy it over. So now that we have our big array, now we can shift everything over, and now everybody has a spot to sit. And then we can put the 4.4 where we originally wanted to put it. So then our final result will look something like this: 4.4, 1.1, and 2.2 with some more spots remaining. All right, so let's actually code this up. So we can get started with the actual syntax for the method. So public void, then the name is insert at, and then your parameters. So we have int index, and then double value. Then we have our curly braces here. So now the first part, we want to see if the array is full. So the way we're going to check if the array is full is we're going to use an if statement. So now we're going to use this dot elements to check if the array is full. So I'll explain it after I type out the if statement. Okay, great. So, whoa, what's going on here? Okay, so we use this dot elements because we want to access the value of next int, and the value of next index, and we used this dot element to access that because next index is private. And so we want to see if the array is filled, then we're going to have to make it bigger. And so the only way we can make it bigger is using the grow method that we already wrote. So we can do this dot grow. Basically, we're saying if the array is full, if there's no room, we're making some room. So that's the first part of our loop, or that's the first part of our insert at method. Now the next part is to actually see if the value is inside of our array. So we can use if 0 is less than or equal to index and where's the and? Okay, and index is less than or equal to next index, then we will increase the value of next index. All right, so now we're also going to be throwing in a loop here. So for int I equals index I, oops, it's greater than or equal to next index I plus plus. This, I'm going to explain it after I type it out. It always defaults to array size. So annoying. Okay. So what this section of the code does is that if the desired index is actually inside of our array, then we're going to increase the value of next index. And the reason we're increasing the value of next index by 1 is because we're going to be inserting another value, which makes the next available index 1 greater. Then we're using this for loop to copy each element in the array over to the next available spot. That way we have room to insert our value at this, we have room to insert our value at the index. So the last thing that we want to do, we opened up an index, but we didn't actually insert a value. So that's where we can do okay. So basically what this code does is if the array is full, oh my God, grow it, then if the index is in the array, make the value of next index +1. Then move elements in the array over 1 spot to make room for the next value. And then this one will insert the value into the open index. And this is pretty much how the insert at method will work. So we just did insert at. Now let's do insert. This one's a little more easy and straightforward. They give us a little bit of pseudocode here where it's just public void insert, then our value. And all we're doing is inserting a value at the location next index. So basically, I'll just quickly draw what's going on here. Oops. Okay. Let's go new. No. Okay. Basically, before we were inserting values at a specific location. Now we're only inserting values at the last location. So right here is our next index. Next index. I'm just going to say next. And let's say we have 1.1, 2.2, 3.3, and we want to insert 4.4. So we just throw it right there. Now let's say that the array is full. And then we're just going to do, let's say 1.1, 2.2, and 3.3. And we want to insert 4.4. Well, just like last time, 4.4 can't go anywhere. The program's going to explode because there's no spot for 4.4. So we can just grow the array just like last time. We'll call the grow method, copy all the elements into here, and then it'll be 1.1, 2.2, 3.3, and now there'll be more spaces for 4.4 to be added into. So we'll just call grow, double the size of the array, then we'll add 4.4 right in. So now that we get the general concept, let's just write it out. So we have our insert at method right here, and we're going to do the same type of syntax. So it's going to be public void. Okay, let's spell it. Void insert. This will require no parameters. Oh, actually, sorry. This is going to require the value. Double value. Um, and basically same thing here. So we could almost copy this over. I would if I wasn't doing a demo, but this elements equals array. This array equals array dot length. And this dot grow. Same thing, and then we're just gonna do, we're gonna say array at the index of next index is going to be equal to the value, and then we're just gonna increment next index because we're adding one more thing into the array, so the next available index will go up. Shoot. As so. And this is actually everything for the insert method. All right, so let's talk about the last few methods here. So the last ones we're going to have to worry about are making our remove at method, our remove method, and our print array method. So the remove at method is probably the most complicated of these three. And it works pretty similar to the insert at method, except this time it only takes one parameter, which is index. They give us some pseudocode again, which is just saying if it's in range, then we're going to move the necessary values over to eliminate the value at the location of the array. So, and then instead of using grow to adjust it, we're going to use shrink to adjust it because we're going down in size in our array. So let's actually draw out what's going on here. Just a quick reference. Let me hop on my MS Paint. All right. So let's say we have an array of values we want to remove. So let's start, we have 1.1, say we have 2.2 in our array, 3.3, and 4.4. And let's just give an empty space just because. Okay, so this is the current state of our array. Let's say we want to remove something at index 1. So let's remove 2.2. So this is index 1. The way that we are going to remove stuff in arrays is actually just overriding the value of the next value. So before we were shifting our values to the right like this to make room for a value, but this time we're removing it. So we're actually going to be shifting our values to the left. Man, I should not have drawn these arrows so big. I don't know, hopefully they have a bigger eraser in MS Paint, I swear. Like this is like the smallest thing, or this is like the biggest thing I could find. So okay, that kind of works. We're actually going to be shifting our values to the left here, and we're going to be giving the value of 2.2 to the value of the one to the right of it, and so on. So our new array is going to look like 1.1, which remains unchanged, and then our value at index 1 is going to be changed to 3.3. The value of 3.3 will be changed to 4.4, and then the value of 4.4, this 4.4 will remain the same as 4.4. So this is what our new array will look like. Now you could leave your array like this for the purposes of this assignment, but if you really wanted to get rid of this last value, you could just set it to null. So you could set the array at the end of your, or the value at the end of your index to null, and that way you would get rid of this duplicate value here. You would just be left with 1.1, 3.3, 4.4. And I tested both ways. The assignment will work the same way if you null the last value or if you don't null the last value. Okay, so now that we kind of have a general idea of how the remove at method works visually, let's actually try to implement it into our program. Close this console here. Okay, just make sure this is the right one. Okay, so first thing we're going to do, public double remove. So double is the return type, and remove at is the name. We need our parentheses, and we're going to need our braces here. This might be too far down. Just give some more room here. All right. So public double remove at parentheses braces. Okay. So the first thing we want to check if it's in range. So if 0 is 0 is less than or equal to index, and index is less than next index, then we can actually we actually have to pass something in here, int index. All right, so now if the value that we're trying to remove is actually inside of our index, then we can actually remove it. So remember, we want to return the value that we removed. So the easiest way to do that is just to put it inside of a variable. So we'll do double, and we'll name this value remove value. You can name it whatever you want, but it'd be easier just to name it something that it's easier to name something that's just like pretty simple. This array at the value of index. It always defaults to array size. Right? Index. And boom. So now we're storing the value we want to remove inside of a variable. But now we still have to actually remove it from our array. So what we're going to do is use a for loop. So we can do for. And then inside our parentheses here, int I equals 0. Oh, no, sorry. Int I will actually equal index because we're going to be starting at the index we want to remove the value at. We're going to do int I equals index. I is less than next index. And then I plus plus. Because we're going to be shifting every value to the right, or sorry, we're shifting every value to the left. So we're still going to be going up in the values, but we're just going to be moving them left for each value we see in the array. Okay, so now that we have our for loop, now that we have the conditions for our for loop, now we actually have to talk about the body of the for loop, which is just going to be this dot array at index I is going to be equal to this dot array at index I plus 1. So we're giving the value dot array. Oh, should just be I plus 1 here. Okay, yeah, so we're just giving the value of the index at, we're giving the value, the current value of our array, or the current value of the index to the one next to it. So actually might be easier just to do this again. So all we're saying is we're giving the value of this to the one next to it, and we're giving the value of this, of the value at this index, to the one next to it. So we're just shifting the values along. Now we don't have to null the value, so I won't. But I will show you how to do it, but I won't leave it in my final code. So after your for loop's complete, you could just say this dot array at next index. Ooh, actually, sorry, we need to go next index minus 1. This is how we prevent out of bounds. This array at next index minus 1 equals double dot nan. And this is how you would just null the last value. I might show later how these are actually going to be the same no matter what. But remember, we still have to return something. So before we return something, we still have to update the value of next index. So next index minus minus because we just removed one value from it. And now we're going to return. Remember, we have to return a double, but we already established our removed value is going to be a double variable, and it's going to be at this array.index. So we could actually just return this. Well, actually, we'll return remove value. And the reason we're returning remove value and not this dot and not the array at the index is because the array at the index is actually going to be changed in our for loop here. Okay. So we have an if statement, and so now we need an else statement here. And now the else statement is going to be very hard. Probably the hardest thing we'll do in this entire thing. It's the hardest thing I did. Else do nothing. So basically we have no else statement. You're still not returning something? Oh, we have to return something type double. So actually we can't do nothing, but we can just return. And this will be fine. Actually, instead of double NaN, I think we could just return null here. Oh, null can't be double. Okay, so yeah, we will do double NaN. Okay, and that's pretty much everything that goes inside of the remove at method. Okay, so let's start with, or let's finish with the last two methods we have to write. So we have to do remove and the print array method. Okay, so the remove and print array methods are pretty straightforward. All that it's asking for is to remove the value of the location at next index -1, and print array is just printing every element inside our array. So to remove an element at the end of our array, we can just code this up. I don't need to hop in MS Paint. I know you guys are begging me to hop in MS Paint. It's your favorite part of these videos, and trust me, it's mine too, but I think you guys can be without it for this time. So all we're gonna do to remove this is, well, first we have to make sure the array gets shrunk correctly. So public double, so this is a return type, remove parentheses braces here, all right. Now we want to make sure this array actually shrinks, so if this dot array size divided by 2 equals this dot elements, then this dot shrink. So all this is saying is if we have twice as many elements, if we have twice as many spaces as elements, we're going to shrink it to make sure it fits. That's just a requirement of the program. And now we're going to say if next index equals 0, then we're going to return double dot NaN, just like this. And the reason we're doing this the reason we're returning double NaN if next index is 0 is just because if we don't have any elements in our array, then we're just going to say null, and then we're just going to say we have no elements, so we're returning null. There's no value to return, basically. And now we're going to actually return a value if there's an element inside the array. So if, or actually we don't need an if, but we're going to need double. So we're going to store this value inside of a variable, just like we did with the remove at method. Array at next index -1. We're doing -1 to prevent out of bounds errors. Now array at the index of next index -1. We're going to set this equal we're going to null this value essentially. So double. So now we're getting rid of the value at the end of the array, and then we're going to return remove value. So this is pretty much everything we have to do. We're going to shrink the array if it's able to be shrunk. Then if there's no elements to be returned, then we're going to return null. And then if there is an element to be returned, then we're just going to say we're going to make this a variable, assign it to next index -1, and then we're going to null that value and then return the variable that we stored it in. All right, and then the last method we have is the print. Oh, one last thing before we do this, we actually have to decrement next index, and we're decrementing next index because if we're removing a value from the array, then the next index is going to be one less. All right, so now we have our last method, and printing an array is pretty straightforward. So public void will be the return type. Print array with 2 R's. Parentheses, braces here. Let's give some more room. All we're going to do is have a for loop going through all the elements in our array. Then I is less than next index. Then I plus plus. And then we're basically just going to print. We'll do print ln. I think it looks a little nicer. This dot array at index I. I hate how it does that. This dot array index I, and that's everything for our print array. So we have all the methods completed, and hopefully we met all the requirements. So let's look into a little bit about what this driver is actually doing. So the first thing it's doing is creating an object, and then it's going to see the size and how many elements are being contained in our object. So the value for this should be, if we're creating an object, it should have the size of 1 and 0 elements because it's just an empty box. Then a variable gets initialized and we're looping 9 times. We would be looping 10 times if we had an equal sign here, but we're only looping 9 times because when the for loop gets, when v here equals 10, it stops immediately. It doesn't keep going after the 10th iteration. So we loop 9 times. And when we loop 9 times, we insert this variable here into our array. So this is testing now our insert method. And then it will display the value inserted at each location. And then this value will be multiplied by 2. So that's what we're doing here. And then it looks like here we're printing out the last value in our array. And now we're going to loop 10 more times and remove them. It's pretty straightforward. We're just going to be printing, after each iteration, it's going to print the value of the last value in our array. And then our insert at method will be tested. And then it'll test remove at twice. Okay, so pretty straightforward. So let's see what our target requirement is. So it's going to go up to 512, then we're going to get null, then we're going to go down to 0. Oh, sorry, we're going to go down to null, then we're going to go 0, 3.0, 6.0, 9.0, okay, all the way to the end. Okay, so let's try to run our program and see if we meet these requirements here. Okay. So it looks like we have an out of bounds exception somewhere. Let's try to figure it out. So this works. It looks like we're able to add, we're able to remove. But now we have a value of null. But if you see here, it says we have a size of 0. Now our size should never be 0. Our size should at smallest be 1. So anytime we see size 0, we already know there's an issue. And I think we know how to fix it. The only thing in our program that actually shrinks is the shrink method. So we have to put in a requirement for the smallest to be 1. So for the shrink method, we could just use a simple if statement. Say if array dot size, or we can use our array size method. If this dot array size is not equal to 1. Oops, 1. And we're going to throw that here. It's like this. So now we're not able to shrink our array if the size is 1, which means that we can't go down to the size of 0. It's impossible. So let's try rerunning this and seeing if that fixes the issue. Okay, so we went up to 512, got null. Then we went down, back to null. Now we have size 1, element 0. So we didn't shrink this time, which is the big difference in the last run as opposed to this run. Our insert at method works. And we've finished the program. So that's everything that's required of us in program 5. Hopefully you liked this video. If you didn't, sorry. And yeah, that's pretty much it. I hope you guys have a great day and see you next time.